Yo, what up, everybody? Today we're going to be talking about how to go from a position versus time graph to a velocity versus time graph. So this is a fairly common question in physics where you're given one type of graph and you have to draw another type of graph that shows the same motion. We do have another video where we go the opposite way from velocity to position, and you're welcome to check out that video as well. All right, so we're going to show you several examples, and hopefully these examples will give you a starting point for any question that you've been given. So when we're looking at a position graph, there's really three things we need to see in order to determine how to draw the velocity graph. The first thing we need to look at is whether it's moving up or whether it's moving down. Okay, so this one is moving up, meaning it's an object that is getting further from the reference point in the positive direction. Second thing we need to look at is what direction does it curl, and this one curls upward. Right, so a curl up would be if it's like part of a smiley face, whereas a curl downward would be if it's part of a like a frowny face. Right, so you can see this is like the right half of a smiley face, so we say there's a curl upwards. If this pattern continued, you can imagine it would just be like a curl up. Then thirdly, what we need to look at is, does it get steeper or does it get flatter? So in this case, you read the graph from left to right, it's definitely getting steeper as you go from left to right. So what does that mean for our velocity graph? What it means is, because this line is moving up, the velocity graph is going to be in the top half. All right, the line is going to be in the top half of the graph. It also means that it's going to slope upwards because the curl is upwards. And because it's getting steeper, we expect that it's going to move away from zero. The line's going to move away from zero in the top half, and it's going to slope upwards. So I'll give you a few seconds, pause the video, and jot down what you think that graph is going to look like. Here we go in 3, 2, 1. There it is, all right? And so you can see that the position graph, it starts basically flat, which means it would have zero velocity, and then it gets steeper and steeper, which means the velocity is getting greater and greater, and it's going to slope upwards like that. All right, we know that it's a positive velocity because it's moving. The position graph is moving upwards. We know this line to be sloping up because the curl is upwards, and we know that the line is moving away from zero because the position graph is getting steeper. In this example, we have another position graph, and we're going to look at those three things again. So one, we notice that this line is moving down, right? From left to right, it's getting closer to the reference point. It is part of a curl upwards, right? Because you can imagine if this pattern continued, it would be like a bowl, which represents a positive acceleration. And you notice that it's getting flatter this time. So what would that look like on a velocity graph? Well, because it's moving down, we know that the velocity graph will be on the bottom, the negative half of the graph. Because it's curling upwards, we know that this velocity graph has to slope upwards. And because this position graph is getting flatter, we know that the velocity graph, the line has to move towards the zero line. So what is that going to look like? Go ahead and pause the video and write down what you think. And we'll have the answer in 3, 2, 1. And there it is. All right, so this graph fits all three of those requirements. All right, this is an example of a negative velocity but a positive acceleration, where the object is moving backwards, so it's in the bottom half of the velocity graph, but it has a positive acceleration, and so this line is sloping upwards, and it's getting closer to zero, meaning the object's slowing down. In this example, the position versus time graph is moving upward. It's curling down this time, so you can imagine this is like the left half of a frowny face, which means that we're looking at a negative acceleration. And then you can also see that the line is getting flatter. So what does that mean for the velocity time graph? It means that the line of the velocity graph is going to be the top half, and the positive half of the graph. It's going to be sloping downward, and it's going to move toward the zero line. So go ahead and pause the video and write down what you think that graph is going to look like. And we'll have the answer in 3, 2, 1. And there it is, right? So you can see that this graph does all the three requirements. In the top half, it's sloping downward because you have a negative acceleration. And it's moving towards 0. And so you can see at the end, it's almost at 0 velocity, just like on the position graph. This line is almost flat at the end. All right, so this is an example of a positive velocity but negative acceleration. All right, so one final example. This position time graph is moving downward, it's curling downward, and it's getting steeper. So the velocity graph must be in the bottom half of the graph. It must be sloping downward, and it must be moving away from 0. So what would that look like? Go ahead and pause the video, and we'll have your answer in 3, 2, 1. And there it is right there. So you see that this line has all three requirements. It's in the bottom half because you have a negative velocity, as you can see from the position graph moving downward. It's sloping downward because you have a negative acceleration, and it's moving away from 0, so it's getting faster and faster, just in the negative direction. All right, so hopefully this helps you go from position versus time graph to a velocity graph. If you need to go the opposite direction, if you're given a velocity graph and need to find the position graph, click on the link to this video, and we have a video to help you find that as well. All right, hopefully this helps, and I'll see you all in another video.